Hi, welcome all of you to the online lecture of B.Sc. Analytical Chemistry. This is Mr. Shinde Achut Ramrao, working as an assistant professor, Department of Analytical Chemistry, Sanjeevani Mahavidyalaya Chapoli. So, dear students, I welcome all of you to this online lecture. So, in last lecture we have learned about the uses of inorganic precipitants. We have discussed three precipitants which is used to precipitate the different types of ions in the last lecture. In today's lecture we are going to discuss about the use of inorganic precipitant, that is remaining use of the precipitant in the gravimetric analysis. So whatever the left from the reagent we will discuss in this lecture. So before going to discuss about the remaining inorganic precipitants, we will recap what what we had learned in the last lecture. So in brief we discuss about the or recap about the last lecture. So let's discuss about the what we will have learned in the last lecture. So what we had learned in the last lecture. So the precipitant, that is use of silver nitrate in the precipitation of the chloride ion. So the AgNO3 silver nitrate, having the formula AgNO3, it is mainly used for the estimation of Cl- ion in the sample. The precipitant, that is AgNO3, reacts with the chloride ion in presence of dilute HNO3 to form a white AgCl precipitate. The reaction is Cl- ion plus AgNO3 in presence of dilute HNO3 will get the white precipitate of silver chloride, that is AgCl plus NO3 minus ion, that is nitrate ion, is the side product. So the resulting white AgCl precipitate is then digested for 2-3 hours and filtered through the ashless Wattmann filter paper number that is 41 or 42. Washed with the water containing HNO3 for 2-3 times using small portion of the liquid, that is dilute HNO3. For the removing impurities, and then after transfer to a pre-weighed crucible, and then it is ignited at about 130 degrees Celsius till a constant weight is obtained, then cooled in a desiccator and weighed as a AgCl precipitate. Finally, from the weight of the AgCl residue, the amount of and percentage of the Cl- ion, that is chloride ion, in the sample is calculated. So this is about the use of AgNO3 in the precipitation of the chloride ion. Then next one is the use of this sulfuric acid, dilute sulfuric acid, in the gravimetric analysis of barium, that is Ba++ ion. The precipitant dilute sulfuric acid has the formula H2SO4. So it is mainly used for the precipitation and estimation of the barium++ ion in the sample. So the precipitant dilute H2SO4 reacts with the barium ion in presence of dilute HCl in hot condition to form a white BaSO4 precipitate as follows. See what is the reaction. Ba++ plus H2SO4 gives, in presence of dilute HCl in hot condition, we will get the barium sulfate white PPT plus in that is what the H plus ion, 2H plus ion. Then the resulting BaSO4 precipitate is then they digested for 1 hour in a contact with the mother liquor, then filtered through a Wattmann filter paper number 40 or 540, washed with the 2-3 small portion of very dilute H2SO4 and then with water, then transferred to a pre-weighed crucible and they ignited at about 500 degrees Celsius in a muffle furnace for on a burner till a constant weight is obtained, cooled in a desiccator and weighed as a BaSO4 precipitate. So finally, from the weight of BaSO4 residue, the amount and percentage of the Ba++ ion in the sample is calculated. So this is about the use of dilute sulfuric acid for the precipitation of Ba++ ion. Then third, that is the reagent, precipitant reagent we had discussed is the barium chloride in the gravimetric analysis for the estimation of sulfur, the sulfate ion. So SO4 minus minus, the precipitant barium chloride has the formula BaCl2. It is mainly used for the precipitation and estimation of SO4 minus ion, that is SO4 minus minus sulfate ion in a sample. So the precipitant barium chloride react with the sulfate, that is SO4 minus minus, in the presence of dilute HCl in a hot condition to form the white BaSO4 precipitate. So the reaction is SO4 minus minus ions plus BaCl2 gives the BaSO4 white precipitate in the presence of dilute HCl in hot condition. The resulting BaSO4 precipitate is then digested for 1 hour in contact with mother liquor, filtered through a Wattmann filter paper number 40 or 540, washed with 2-3 small portion of very dilute BaCl2 and then with water, transferred to a pre-weighed crucible, ignited at 500 degrees Celsius in Muffle furnace or on a burner with constant weight of 10, then cooled in the desiccator and weighed as BaSO4. Finally, from the weight of BaSO4 residue, the amount of percentage of BaSO4 minus minus in the sample is calculated. So this is a recap of the last lecture, that is what we had discussed in the last lecture. Then we will see in today's lecture we are going to learn about the another some reagent, that is precipitant, which is used for the estimation of different ions. So let's start with this. So use of what the ammonium hydroxide in the gravimetric analysis of iron, that is ferric Fe+3 ion. The precipitant ammonium hydroxide has the formula, that is NH4OH. It is mainly used for the precipitation and estimation of ferric ion, that is Fe+3 ion in the sample. The precipitant ammonium hydroxide reacts with the Fe+3 ion in hot condition to form a red OH thrice precipitate as follows. See what happens, see what is the reaction. Fe+3 plus 3 NH4OH, that is ammonium hydroxide precipitant, and ferric ion which reacts in the hot condition gives a FeOH thrice, that is red PPT, very fine PPT is there, plus 3 NH4 plus ions. So the resulting FeOH thrice precipitate is then digested for 0.5 to 1 hour, then in contact with the mother liquor, then filtered through a Wattmann filter paper number 41, washed with a 2-3 small portion of the dilute ammonium hydroxide solution, then the transfer to a pre-weighed crucible, then ignited at about 700 degrees Celsius and Muffle furnace or on a burner till a constant weight is obtained, cooled in the desiccator and weighed as Fe2O3. Finally, from the weight of the Fe2O3 residue, the amount of the percentage of the Fe+3 ion in the sample is calculated. So this is the procedure for that is for the use of ammonium hydroxide for the estimation of ferric ion by means of the precipitation. So the precipitant is ammonium hydroxide. So the precipitant ammonium hydroxide has the formula, that is NH4OH. It is mainly used for the precipitation and estimation of ferric ion in the sample. The precipitant ammonium hydroxide reacts with Fe+3 ion in a hot condition to form a red FeOH thrice precipitate as follows. So Fe+3 plus 3 NH4OH gives the, in hot condition we will use the FeOH thrice plus 3 NH4 plus. The resulting FeOH thrice precipitate is then digested for 0.5 to 1 hour in contact with mother liquor, filtered through the Wattmann filter paper number 41, washed with 2-3 small portions of the dilute ammonium nitrate solution, then transferred to a pre-weighed crucible, then ignited at about 700 degrees Celsius in muffle furnace or on a burner till a constant weight is obtained. Cool in a desiccator and weighed as a Fe2O3. Finally, from the weight of Fe2O3 residue, the amount of percentage of Fe plus the in the sample is calculated. So this is about the estimation of Fe plus the ferric ion by using ammonium hydroxide. The next is the use of organic precipitant in the gravimetric analysis. So use of the dimethyl glyoxime, that is DMG, in the gravimetric analysis of nickel. So the precipitant dimethyl glyoxime has the formula C4H8O2N2 and having the structure that is CH3 CH3 C double bond NHOH and C double bond NHOH, that is glyoxime. Two oximes are there in the glycol position, that is what the in the adjacent carbon. So it is nothing but the dimethyl glyoxime. So it is mainly used for the precipitation and estimation of nickel in a sample. The precipitant DMG reacts with the Ni plus in the basic or ammonical medium to form a PO box red colored nickel dimethyl glyoxime precipitate as follows. So what is the precipitate formation reaction is that the precipitant dimethyl glyoxime DMG has the formula that is C4H8O2N2 and the structure is CH3 C double bond NHOH C double bond NHOH and CH3. So it is mainly used for the precipitation and estimation of nickel in the sample. Estimation and precipitation reacts, that is the precipitant DMG reacts with the Ni plus in the basic or ammonical medium to form the, that is PO box red colored dimethyl glyoxime precipitate as follows. See what is the reaction. So reaction is, see how this form the red complex, that is post box type of the complex. So Ni plus 2, that is 2 molecules of DMG CH3 C double bond NHOH CH3 C double bond NHOH. So we will get the we can remove the 2H from the DMG dimethyl glyoxime and we can able to bind the central metal atom by means of the gillette, forming the ring like structure. See here. So CH3 NH, and then the resulting NAD dimethyl glyoxime precipitate is then digested for 1 hour and after that in contact with mother liquor and filtered through the previously weighed silica, that is sintered glass crucible, washed with 2-3 small portion of the dilute dimethyl glyoxime solution or cold water, dried in a oven at 120 degrees Celsius till a constant weight is obtained, cooled in a desiccator and weighed as a nickel dimethyl glyoxime precipitate NiC4H7O2N2 bracket twice. So finally, from the weight of Ni dimethyl glyoxime residue, the amount of the precipitate of Ni plus in a sample is calculated. So this is about the use of the DMG, that is dimethyl glyoxime, for the estimation of nickel by means of the organic reagent. See what happen when there is dimethyl glyoxime having the formula, general formula. First, that is the formula is C4H8O2N2 and the structural formula is CH3 C double one NOH CH3 C double one NOH. It is mainly used for the precipitation and estimation of nickel in the sample. The precipitant DMG reacts with the Ni in basic as well as ammonical medium to form the post box like red colored complex, that is nickel dimethyl glyoxime precipitate. Then After that, this reacts with which form the ligand chelate compound with the nickel. So the resulting NRDMG methyl glycoside precipitate is then digested for 1 hour in contact with the mother liquor, filtered through the previously weighed silica crucible, and washed with 2-3 small portion of the DMG solution or cold water, dried in oven at 120 degrees Celsius till a constant weight is obtained. They are cooled in a desiccator and weighed as a NR dimethyl glycoside precipitate, that is NiC4H7O2N2 and twice. So finally the weight of the NR dimethyl glycoside residue, the amount of and percentage of nickel in the sample is calculated. So next use is the 8-hydroxyquinoline oxime in the gravimetric analysis for the estimation of aluminum plus 3. So the precipitant 8-hydroxyquinoline has the formula C9H7ON and following structures. Here structure is 8-hydroxyquinoline. This is the whole is the quinoline compound, and if we get number from the nitrogen 1, 2, 3, 4, 5, 6, 7, 8, at the 8th position oxygen is present, so hydroxyl group. So 8-hydroxyquinoline oxime is the name. It is mainly used for the precipitation and estimation of aluminum in the sample. So the precipitant oxide reacts with aluminum in acidic medium to form the yellowish green colored 8-hydroxyquinolinate and precipitated as the precipitant. So the precipitant that is precipitated as the compound, that is nickel. So the aluminum. So here what the 8-hydroxyquinoline oxime, 8-hydroxyquinoline reacts with the that is forms coordination compound with the aluminum to give the chelate compound. So the resulting Al8-hydroxyquinoline precipitate is then digested for 0.5 to 1 hour in contact with the mother liquor, filtered through the weighed silica crucible or sintered glass crucible, washed with 2-3 small portion of the cold water or very dilute oxygen solution, dried in a oven at 130 degrees Celsius till a constant weight is obtained, cooled in a oven at 130 degrees Celsius and till a constant weight is obtained and cooled in a desiccator and weighed as a Al8-hydroxyquinoline nitrate, quinolinate, and finally from the weight of aluminum 8-hydroxyquinolinate residue, the amount of percentage of Al plus 3 ion in the sample is calculated. So this is about the estimation of Al plus 3 by means of the using 8-hydroxyquinoline. So once again I am repeating the procedure. So what is the procedure for the determination of 8-hydroxyquinoline or that is 8-hydroxyquinoline for the estimation of aluminum. So the preparation of 8-hydroxyquinoline oxime has the formula C9H7ON and the following structure, that is like quinoline, and the hydroxyl group present at the 8th position. It is mainly used for the precipitation and estimation of aluminum in the sample. The precipitant oxime reacts with the aluminum in acetic acid medium to form the yellowish green colored 8-hydroxyquinoline precipitate as follows. See, after formation of the precipitate, that is green colored precipitate, and then this reacts with the aluminum, gives the chelate compound 8-hydroxyquinolinate. The resulting Al8-hydroxyquinolinate precipitate is then digested for 0.5 to 1 hour in contact with its mother liquor, filter through the pre-weed that is sintered glass crucible, washed with 2-3 small portion of the cold water or very dilute oxygen solution, dried on a oven at 130 degrees Celsius till a constant weight is obtained, cooled in a desiccator and weighed as a aluminum 8 hydroxyquinolinate, and finally from the weight of 8 hydroxyquinolinate residue the amount and percentage of aluminum in the sample is calculated. And after that, the use of alpha benzoin oxime, that is cupran, in the gravimetric analysis of the copper. So the precipitant alpha benzoin oxime, that is cupran, has the formula that is C14H13O2N, and the structure is following, that is benzene ring CHOH, C double bond N OH in benzene ring. So alpha, it is known as alpha benzoxime or cupran. It is mainly used for the precipitation and estimation of copper sample. So this is the reaction is nothing but that is the precipitant cupran reacts with the copper plus in the aqueous ammonical medium to form a green Cu alpha benzoin oximate precipitate as follows. So Cu plus the compound, that is alpha benzoxime cupran, gives the compound which forms the that is complex with copper through the oxygen binding, and the resulting Cu alpha benzoximate precipitate is then digested for 0.5 to 1 hour in contact with its mother liquor, filtered through a previously weighed sintered glass crucible, washed with a 2-3 small portion of dilute ammonia solution, and dried in oven at about 150 degrees Celsius till a constant weight is obtained, cooled in a desiccator and weighed as a copper alpha benzoximate, and finally from the weight of copper alpha benzoximate residue the amount of percentage of Cu plus ion in the sample is calculated. So this is about the estimation of copper by means of the cupran. Then last, that is nothing but 1,10 phenanthroline in gravimetric analysis for the Fe plus 2 ion. The precipitant 1,10 phenanthroline has the formula C12H8En2 and the following structure. This is the structure. 3 benzene rings are there, 1 and 10 position the nitrogen is present, and the phenanthroline ring is there. So this phenanthroline is used for the estimation of the iron. So it is mainly used for the precipitation and estimation of the ferrous Fe plus 2 ion and in the sample. So the precipitant 1,10 phenanthroline reacts with the Fe plus 2 ion in slightly acidic medium to form red colored Fe 1,10 phenanthroline net precipitate. So we will get such type of precipitate Fe plus 3 phenanthroline, that is 1,10 phenanthroline. Then it reacts with the iron, form coordination compound, that is phenanthroline thrice compound. So the resulting 1,10 phenanthrolinate precipitate is then digested for 0.5 to 1 hour in contact with its mother liquor, filtered through the previously weighed sintered glass crucible, washed with 2-3 small portion of the dilute reagent of water, dried in a oven at about 120 degrees Celsius till a constant weight is obtained, cooled in a desiccator and weighed as a Fe 1,10 phenanthroline, that is Fe C12H8En2 thrice. That is finally from the weight of the 1,10 phenanthroline residue the amount and percentage of Fe plus in the sample is calculated. So this is about the use of 1,10 phenanthroline in the estimation of the that is ferrous ion. So this is about the estimation use of the different organic and inorganic precipitant for the precipitation of the different types of ion or estimation of different types of ion. So in this we have completed the third unit of this paper number 14. That is nothing but basic analytical chemistry, and in last lecture we will start with the new topic from this paper or the other paper. If you have any queries regarding this topic, please comment your question in YouTube comment box. So thank you, thanks a lot, have a nice day.